May 5th, 1961, Freedom 7. The United States took the first small step on its journey to the moon. America's first man in space, Alan Shepard, rode the Mercury capsule. Lifted to 116 miles by the Redstone rocket's 78,000 pounds of thrust. 10 years later, the launch vehicle is Saturn V, with a thrust of 7.5 million pounds. On January 31st, 1971, the crew of Apollo 14 would leave Earth on their mission to the moon. The man who began our first decade of manned spaceflight would command the mission that would close that decade. Alan Shepard. With him, Stuart A, who would orbit the moon alone while Shepard and Edgar Mitchell explored its surface. Their destination, a rugged area of lunar highlands called Fra Mauro. Apollo 13, aborted as it neared the moon, had been unable to land at this site. Now, we were trying again. But why Fra Mauro?
What happened to the moon during its first billion years, a period erased on Earth? How do the Earth and moon differ in overall composition? By visiting Fra Mauro, we hope to sample the very bedrock of the moon, material very different from that so far collected, material perhaps dating back to the beginning of the solar system.
How can you think of the soil being 4.5 billion years old when igneous rocks which presumably underlie it are only 3.5 or 3.7 billion years old?
This, I suppose, will be dramatically refuted or confirmed at the Apollo 14 mission when they actually visit Fra Mauro.
Most of the activity is associated with one place on the moon, and we have tentatively located that place in or near the crater Fra Mauro.
Everything went smoothly during Earth orbit and for the burn that sent Apollo 14 toward the moon. Then Stuart A moved the command module Kitty Hawk to a docking with the lunar module Antares, still attached to the third stage of the booster.
And we docked. We're unable to get a capture.
Twice they tried. 3 times.
Okay, Houston, I hit it pretty good and held 4 seconds on contact, and we did not latch.
Roger. We're seeing it all on TV here.
Well, we better back off here and think about this one, Houston.
As the astronauts waited, an identical docking probe was brought into mission control. This probe on the command module fits into a funnel-like device on the lunar module called the drogue. Tiny catches on the probe's point engaged the drogue. It was these capture latches that were not holding. In space, the astronauts tried a 4th time. And a 5th.
No latch. No latch, Houston.
Roger.
In space, on Earth, they searched for a solution. Then, on the 6th try,
I believe I got a hard dock, Houston.
as they coasted to the moon, the crew brought the probe inside the spacecraft for examination. On Earth, the probe was tested and retested, for we had to be sure that the probe would work for the most critical docking, as Shepard and Mitchell returned from the lunar surface. On February 4th, Apollo 14 went into orbit around the moon.
This is really a wild place up here.
As Apollo 14 was on its first orbit, the third stage of the booster smashed into the moon at its planned target point. Its impact picked up by the seismometer left by Apollo 12. The structure of the moon's interior is one of the major mysteries of lunar science. Now another piece was added that could help solve the puzzle. Later that day, Shepard and Mitchell climbed into the lunar module Antares and undocked prior to descent.
And we're free.
Beautiful.
Very good.
But as they checked out the lunar module, a problem appeared. An erroneous abort was being signaled on board Antares and in mission control. Should this occur during the landing burn, Antares would abort automatically, and the landing would be off. The mission control team had 2 hours, the time of one lunar orbit, to find a solution. Flight controller Dick Thorson diagnosed the trouble as a loose particle in the abort button. The burden then came to rest on the shoulders of computer programmer Donald Iles. Working against time at MIT in Cambridge, Massachusetts, he reprogrammed the lunar module computer to ignore the false signal. This new program was then checked out in a simulator at Cape Kennedy. As Antares came into contact with Earth again, the instructions were sent up to the crew.
Antares, Houston, the computer's yours.
Thank you. You troops did a nice job down there.
That was beautiful.
Less than 10 miles above the lunar surface, Shepard and Mitchell swept across the landing site.
And Antares, Houston, your go for Fra Mauro.
It's a beautiful day to land at Fra Mauro.
Then, another problem. The landing radar, which would tell them their altitude above the lunar surface.
On radar. On radar.
Antares, Houston, would like you to cycle the landing radar breaker.
Okay, cycle.
Okay, I would like to accept the radar.
Breaking. Oh, great. Great. Oh, that was close.
Okay, and monitor descent fuel.
That's starting the camera.
10 seconds to go.
Okay, there's pitch over.
Right on
There it is.
Right on the money.
Right on the money.
That's beautiful.
Right out the window, just like it should be.
Antares, Houston, your go for landing.
Cone Crater, a major objective of this mission to Fra Mauro. A hole blasted in the moon's surface eons ago that could provide a scientific clue to the history of the moon, the Earth, and the solar system.
Right on schedule. Right on schedule now. One back Cone Crater right outside to my right.
We think that the Fra Mauro area was formed from material thrown out by the impact that created the Imbrian Basin to the north. If this is the case, we could get samples torn out from as deep as 60 miles in the lunar crust. All in all, the Fra Mauro material should contain a great deal of new information about the early history of the moon, and thus help us to better understand the formation of our own Earth.
Okay. Okay, I'd give it a few clicks. You're through 200 feet. About 8 per second. That looks good.
No metal here.
9% fuel looks great. Okay, looks like you're going right over the middle of triplet. You're 170 feet out, 2 feet per second down, 8% fuel. You're looking good. Okay, you can move on forward. You're just barely crossing North Triplet. Barely crossing North Triplet. You can land over here. There's the dust, Al. You're on your own.
Starting now. Starting now.
Okay. There's good dust. Watching down. Looking great.
60 seconds.
40 feet. 3 feet per second. 30. 3 feet per second. Looking great. 20 feet. 10. 3 feet per second. Contact, Al.
New stop. Auto.
We're on the surface.
Okay, we made a good landing.
Roger, Antares.
5.5 hours later, Shepard left the lunar module to begin the first of 2 explorations.
Shutting down the ladder. Roger.
10 years later, 114 hours, 22 minutes after leaving Earth, Alan Shepard stepped onto the moon.
It looks like you're about on the bottom step and on the surface. Not bad for an old man. Okay, you're right. Alan's on the surface, and it's been a long way, but we're here.
4 minutes later, he was joined by Ed Mitchell.
The last one is a long one.
Following the tradition of 2 previous missions, Shepard and Mitchell planted the flag in the lunar soil.
How's this, Bruce? Look okay? Roger, that's a good sight.
The next job was to load the Met, a rickshaw-like wagon the astronauts would use to transport their tools of exploration and collected samples.
One of the big factors in lunar exploration is mobility. In Apollo 14, we had the MAT, which let us move further afield than the previous 2 missions. In future missions, we'll use the lunar rover, a sort of moon-going dune buggy. This mobility will mean less time spent in getting from here to there and more time collecting scientific data.
Okay, I'm going to stop here and rest for a minute. I'll lift everything heavier than I expected.
Shepard pulled the Met while Mitchell carried the barbell-shaped package containing an automatic scientific station they would assemble. A station designed to continue broadcasting data to Earth for a year after men departed Fra Mauro.
Okay, Houston, we're proceeding over a very fine-grained regolith we described before. Good heavens, that's a deep hole. Going down in a depression. Deep, very deep depression. That is what it looked like. Roger, you're visible from about the armpits up right now. Nothing like being up to your armpits in lunar dust.
Finding a suitable site to place the scientific instruments was the next order of business. Shepard and Mitchell now began setting up the automated scientific laboratory. A small nuclear generator to power the array. The central station to transmit data to Earth. A seismometer to detect and measure activity on and within the moon. A series of 3 experiments to measure charged particles near the lunar surface. An independent experiment to reflect laser beams from Earth, enabling extremely precise measurements of such things as Earth-to-moon distance, the wobble of the Earth's axis, continental drift, and shifts of the Earth's crust. And a mortar to be fired by a signal from Earth sometime within the next year. The impact of its charges would be picked up by Apollo 14's seismometer. As a final exercise, Mitchell used the thumper, a device to explode a series of controlled shotgun-like charges. The vibrations from these detonations were picked up by a series of instruments he had previously deployed. With the instruments set up and operating, they headed back toward Antares, pausing on the way to collect samples. They loaded their 44 pounds of lunar material aboard the lunar module, and after 4 hours and 50 minutes on the surface, climbed back into Antares. As Shepard and Mitchell rested, Stuart Rossa continued his work from lunar orbit. His photographs would have meaning not only to the scientific community, but would have direct bearing on the planning for coming missions.
Yeah, it's nice to be up. A sunny day again. Yeah, it's a beautiful day here at Fra Mauro Base.
12 hours, 40 minutes later, Shepard and Mitchell began their second exploration period. After loading the lunar rickshaw, Mitchell began the journey to Cone Crater. Shepard adjusted the television camera, then hurried to join his partner.
Okay, Houston, we're headed just about toward the center of Cone Crater. Okay, point A, Al, is right. It's not quite in the valley, it's right beyond over here. Okay, this is probably pretty good.
Point A, the first stop on the trip to Cone. Here they would collect and document samples, measure the local magnetic field, and take core tube samples from beneath the surface layer.
This is a good place for A. They have an appearance here quite often like raindrops, a very few raindrops have splattered the surface.
The quality of the scientific description by the astronauts could be termed by Earth-based scientists only as excellent. But now Shepard and Mitchell pushed on. After a brief stop at a second survey site, they began their assault on Cone Crater, a climb not only toward the summit of a lunar mountain, but back through time.
A large crater acts in many respects like a drill, throwing out material from deep beneath the surface. This material should be very different from any we've collected before, perhaps dating back to the origins of the moon and even the solar system.
And we're starting uphill now. Climb's fairly gentle at this point, but it's definitely uphill. Why don't we pull up beside this big crater, take a break, get the map, see if we can find out exactly where we are.
The maps they were using had been made from photography from lunar orbit. The hummocks, craters, ridges, and boulders took on a new appearance when seen from the surface.
The limb looks like it's got a flat over there the way it's leaning. Start on up toward the rim? Yeah, just 1 second though. Hey, pull a while out. We're having all the fun. And the grade's getting pretty steep. Al's got the back of the mitt now, and we're carrying it up. I think it seems easier.
Well, I tell you, we're really going to get a panorama. We got a tremendous one here, Houston, already. And we're not quite to the rim.
But the rocks and boulders getting more numerous toward the top here.
Okay, well, now that's apparently the rim of Cone over there. And we're about almost 2 hours now. That's at least 30 minutes up there.
It's going to take longer than we expected.
Now they were working against time, against the oxygen and water left in their backpacks, against the alien terrain. Top a ridge, thinking it's the rim of the crater, and there's another ridge ahead of you.
I don't think we'll have time to go up there.
Oh, let's give it a whirl. Gee whiz, we can't stop without looking at the Cone Crater.
Okay. Well, press on a little further, Houston, and keep our eye on the time.
Okay, and so right now we have a 30-minute extension.
Looks like we'll be approaching the rim here very shortly. Okay, we better reconnoiter here. I don't see the crater yet.
Standing in a boulder field surrounded by rocks 10 to 12 feet long, the astronauts made their most difficult decision. With the concurrence of Mission Control, they stopped their climb, less than 150 feet from the edge, to begin the more important job of collecting samples.
The crew had no way of realizing they were so close. It was a week after the mission before we determined this by photographic analysis.
While they could overcome the terrain, they could not beat the steady drain of oxygen from their backpacks. In the terms of scientific meaning, the decision not to go on to the rim meant little. In human terms, a great disappointment.
One of these boulders, Fredo, is broken open. They're really brown boulders on the outside, and the interface that's broken is white. And there's another one that most of it is white. They're right in the same area.
The white rock is of different composition to the Apollo 11 and 12 rocks. In fact, the chemistry of all the rocks that have been looked at so far is different to those rocks. Potassium and uranium are 10 times higher, which are the sort of values we might expect if the Fra Mauro rocks represent ancient lunar crust, which of course is what we're all hoping.
Again, it was time. Time to head back to the lunar module.
Approaching the rim now. Coming into Fra Mauro base.
After a quick side trip to check on the science station, they loaded the lunar module with samples and data and stepped off the lunar surface. The second expedition had lasted 4 hours and 35 minutes, a total exploration of a record 9.5 hours. 33.5 hours after they landed, Alan Shepard and Edgar Mitchell lifted off in the silent vacuum of the moon.
Gas engine is armed. 6, 5, 4, 3, 2, 1, 0. We have ignition. What a liftoff. And liftoff. Roger, ignition. Boom. Switch over. 10 seconds. Roger. Hey, baby. Switch over is good. Steering looks good, Houston. Roger, you're looking good from down here, Al. I'll be up on 1 minute.
Half an hour later, Stuart Rossa watched their progress from Kitty Hawk.
What are you doing way down there, oh fearless one? You've lost a little weight since the last time I saw you.
Houston, entering the station, keeping at about 100 feet, closing in a little more for the victims of the service module and command module.
Okay, I shall do a loop later.
Okay, make it smooth.
And around we go.
Show us a little style. Oh, you look good.
There I was at 240,000 coming over the top.
That's our home away from home. Would you believe 360,000? Yeah. Kitty Hawk is doing an extremely smooth loop. We're sitting at 70 feet, watching him go around. He looks very clean.
The inspection complete, Antares and Kitty Hawk moved together for docking.
Apollo 14, this is Houston. Your go for the docking. Roger, we got you.
Okay, we captured. And we got a hard dock.
That big sigh of relief being breathed around here.
They transferred the gear from Antares to Kitty Hawk, buttoned up the tunnel, then jettisoned the lunar module. It would crash into the moon at a predetermined spot, its impact picked up by their seismometer and the seismometer left by Apollo 12 over a year earlier. 149 hours after they left Earth, they performed the burn that broke them out of lunar orbit. During the coast to Earth, there would be time to catch up on sleep, relax, and do all the little things left undone. And there was one more item, a series of scientific demonstrations in zero gravity, demonstrations impossible to reproduce on Earth. These trials looked at basic physical properties of matter in zero gravity, studies that could lead eventually to new materials manufactured in space for use on Earth. On February 9th, 1971, 9 days after they left Earth, the crew of Apollo 14 hit the atmosphere of their planet at a speed of over 24,000 miles per hour. They hurtled toward Earth, a meteor heading home. On board, 95 pounds of the moon.
Extremely important. It relates to the question of why we're fooling around with the moon. It's really that the imprint of history, the solar system history, on the Earth-Moon system is centered on the moon for the first billion years. What we hope to gain is, we've got a window right now between t equals 0, the beginning of the solar system, and when the Earth so totally messed up itself that we can't look at it anymore. We'd like to look in there, and that window's on the moon.
Apollo 14 has already had a very big scientific impact, and we still have 3 missions left. They'll be heading into even more rugged and more interesting areas of the moon. Beginning with Apollo 15, the lunar rover will let us range further afield and collect more and more varied scientific samples and information. The study of the moon and how, for instance, elements and minerals are distributed in its crust will enable us to learn more about the process of crust formation on Earth, leading to a better understanding of the way that certain elements concentrate in the crust. Will we have had enough missions to the moon by the end of the Apollo program? Probably not. You can never have enough knowledge, but at least it's an excellent beginning.